Hello and welcome to the 2022 ACEC Civil 3D workshop. My name is Keith Sowinski. I am the Civil 3D Implementation Engineer at the Wisconsin Department of Transportation. In this session, I'll be presenting on some of the advancements we've made with the WisDOT Civil 3D configuration. This will not be an exhaustive list of what we've done, and I'll be focusing mostly on the new and enhanced tools we provide. For a full listing of what's new since last year, visit the WisDOT Civil 3D knowledge base. This has been a very busy year for us. Not only did we implement Civil 3D 2022, but we've focused on a number of other themes, including QTO, contractor data packet, and visibility checks. Let's get started. First, we implemented Civil 3D 22 in the spring. For this implementation, we had a number of goals. We wanted to use this opportunity to get all WisDOT staff using the same version of Civil 3D. The consistency in the DWG format and our template standards made this possible. I'm very pleased to say that besides a few remaining projects using Civil 3D 2016, WisDOT staff are all using the same Civil 3D version. This helps us keep our standards consistent across projects and staff. It also gives our staff more certainty when working on various projects, knowing they don't have to check which version of Civil 3D they should be using. Our hope is that we will be able to keep moving forward as one as new versions are implemented. Second, we made a number of improvements with our configuration related to performance and usability. Loading our AutoCAD components into drawings is much more functional and faster than in past versions. For example, in addition to loading quicker, our layer states will now apply to XREF layers. This makes sheet production much more efficient. We also made some of our settings persistent, even when running updates. For example, if you disable our reference templates, that is now stored as a system variable, so that setting is saved if you run a WisDOT update. Finally, we've made many of our tools more accessible by adding them to object right-click menus when it makes sense. Let's get started looking at some of the tools. First, we've made some improvements to QTO functions. We have two new reports, one for lengths and one for areas. These reports output to Excel with tables of lengths and areas. They give the station range of all the objects, and for areas, they even label the areas if you desire. All the station measurements also have precision options. So here's an example of the output for the lengths report. You can see each object gives a station range, the location being the alignment it references, as well as the length. We've also added a feature to show what layer each object was on, so you can stay more organized. The areas report is also similar. It gives the station range for each area, the location being the reference alignment, as well as the area. And you can report the area in either square yards or square feet. As you can see, it also gives you the layer of the objects. We have a new and improved earthwork detail report. What's nice about the new earthwork detail report is it takes the data directly from the sample line group and goes straight to Excel. There's no more exporting extra XML files and running a separate tool on the side to get your earthwork detail reports. Not only that, but we also updated the formulas in Excel so that when you start deleting columns that you don't need, the remaining formulas will still function. If you have updates to your earthwork, you can always rerun the reports and overwrite the old ones. The remaining earthwork summary will still find the data that's needed because it's all based on named ranges. Let's do a quick demo. In this example, I have 4 separate DWG files that all need earthwork run on them. Let's try running the reports. I'm going to go to the WisDOT Design tab, Analyze panel, and click on QTO. Here I'll find the earthwork detail report. So with the earthwork detail report, you pick the starting sample line for the range that you want to calculate earthwork. In this case, I'm going to just select the first sample line, but you can select anywhere in the sample line group. And then I can either go ahead and select whichever sample line I want to end on, I'll select the last one. Or if I wanted to, I could also just hit, if I know I'm going to use the last sample line, I could just hit end sample line and it'll grab the last one. Then I'll grab the material list. I only have one in this case. And I'll start filling in my factors. I'll create a worksheet name. And I'll go ahead and save a file. I'll just call this earthwork. I'll create the report. Here I can go ahead and just review the results and go ahead and close the file. I can then move on to the next file and do the same process. All the settings will stay the same. You don't have to close the dialog box. I just need to reselect my sample lines. And we'll call this a new worksheet name and run the report. And now you can see we have the next report available. I'll do this for the remaining reports. And that's all there is to it. I now have my 4 earthwork reports. And just for example, I know I don't have marsh or rock or EBS on these, so if I were to delete these columns, you can see all the values are still computed for fill and for mass ordinate. So the next step would be to run your earthwork summary. That's where the new WisDOT Excel add-in for Civil 3D comes into play. This add-in includes a number of tools. One, to quickly create data link named ranges for creating tables in Civil 3D. One for quickly formatting station values out of numbers, and one for adding lines for your tables. And then finally, the earthwork summary. Let's focus on the summary. Now that I have all my earthwork detail reports created, I can make my summary. I'll go to the WisDOT Civil 3D tab and I'll click Earthwork Summary. I'm presented with a new dialog that asks which sheets I want to include. If I want to break these into multiple divisions, I can do that at this time. I'll also put in my earthwork factors in the fields below. I'll click OK. And we now have our earthwork summary. You can see the columns that we were deleting on the one earthwork detail report because it says range not found. You can see we're not going to be using those columns for any of these, so I can go ahead and remove those. Let's take a look at a few of the other tools included in the WisDOT Excel add-in. We've got one for, I'll just start a new sheet. We've got one to take numbers and format them as stations. So I'm just going to put some random numbers in here. And if I were to select these, I can choose which station precision I want, hit Format Station, and now they will appear as station formatting. I've got the Line Every tool, which allows me to select a range. And let's say I want to line every 5 rows, and I want to include a line at the bottom of the last row. I check this box. I got my line every. Let's say I didn't really want to start there. I wanted to start up here. I could do it again. It'll overwrite those lines. So a really quick way to get lines in your tables. The last tool included in the WisDOT Civil 3D add-in is the Data Link Named Range tool. So for example, I'll just go to one of these earthwork reports, and let's say I wanted to take and put this earthwork report into a table in Civil 3D. I would just select the range and I'd hit the Data Link Named Range. You can see it gives it a standardized name. So that brings us to our next tool, which is the Create Data Links and Tables tool in Civil 3D. So this offers up an alternative approach or alternative method to getting Excel tables into Civil 3D for things like miscellaneous quantity sheets or earthwork sheets, things like that. So instead of doing the traditional copy, paste OLE object in Civil 3D, we're going to create these named ranges in Excel and then connect to them using data links. The Create Data Links and Tables tool makes it a very quick process to create all the data links necessary to create the AutoCAD tables. When you connect the tool to an Excel file, it finds all of the named ranges in the file. And then since we have the tool in the WisDOT Civil 3D add-in that creates standardized naming for your named ranges, and you quickly go through your entire workbook creating these named ranges, you can select your named ranges, and then you just create the data links all at one time without having to do them one by one. Once you have the data links created, then you can create the AutoCAD tables, and that's the second tab on the tool. You go to the Tables tab, you select the data links that you want, and then you can create all your AutoCAD tables at one time, or you can create them one at a time. So the benefit to this is this creates searchable PDF output. So for example, maybe you wanted to search for a particular bid item on your miscellaneous quantity sheets. With the traditional paste OLE object, those do not result in searchable text, where this will result in searchable text on your PDF files. Not only that, but these tables then remain dynamically connected to your Excel document. If your Excel document changes, the data links are connected to that and they'll update accordingly. For more information on this tool and workflow, check out Mitch Lavin's presentation on Wednesday morning at 8:30. Excel to Civil 3D, creating quantity sheets in Civil 3D. Now let's focus on some of the things we've done to make the contractor data packet easier to put together. First, we've enhanced the design surface data extractor. The big enhancement here is you no longer need to specify the data shortcut project folder. There's been some new API improvements with Civil 3D and data shortcuts that have been recently added, and we've harnessed that with the design surface data extractor so you don't need to specify the data shortcut project. This also makes it easier so that when you point the design surface data extractor at your final surface, it can easily find all the objects that are contributing to the break lines. And then you can get your break lines files with less errors. We also went back and looked at the design surface data extractor to make sure that it can handle multiple layers of file nesting when it's looking for the source documents or source DWGs. We think you'll find that the tool works much better than it has in the past. Part of the process of putting your contractor data packet together is getting those break lines. And you need to validate your break line file to make sure you have all the break lines that are necessary for the contractor to build their construction surface. The way to do that is to take the break lines you have, build a surface out of it, and see how it compares to your final refinement surface in Civil 3D. That's what this new tool is all about, the Create Verification Surface. Once you have your break line file, you point this tool at your refinement surface in your break line file, and it'll create a verification surface. It does this by taking all the break lines, it puts them in another drawing and creates a surface. Then it data references your refinement surface and compares the two. It compares them by using a volume surface, and you'll be able to see any areas where there may be inconsistencies. If you haven't been verifying your brake line files to date, we highly recommend that you start doing so. These brake lines are one of the most important components of our contractor data packet. Finally, we've added a new tool to help verify the integrity of your contractor data packet zip file. It's called the CDP Integrity Report. This tool checks your contractor data packet zip to make sure there's no Civil 3D objects, no X references. It verifies the XML structure of your XML files. It checks for the proper metadata files, and it checks for your DT1773 file. One thing to note about this tool is it only checks for content. It's not checking to make sure your surfaces look good or all your brake lines are there. It does not check for quality. It only checks for content. Let's do a quick demo to see how this works. So to use this tool, you don't have to have any particular drawing open. You find the tool on the WisDOT Design tab, Contractor Data menu, and at the bottom you'll see CDP Integrity Report. Here I'm going to go and select my contractor data packet zip file. And I'll click Open. And by default, it'll save the report in the same directory as your zip file. But you can change this if you want to. Hit Create Report. Here I've already ran the report, so just letting you know that it's going to overwrite that. I'll go ahead and do so. And it gives you a progress meter to let you know that it's moving along through the files and building the worksheet. So here you can see it lists that it flagged that the DT1773 was not present. And then it goes through each of the files in your contractor data packet and lets you know if it passes or does not pass. If it fails, it tells you what's wrong with it. Here's an example where a pavement file, it found Civil 3D objects, meaning it hasn't been exported to AutoCAD. So that's something that needs to go back and verified. It'll also look for things like extraneous files that are not needed. Here you can see there's a series of BAK files that are not needed in the contractor data packet. We highly recommend you run this tool for your contractor data packets. This is the tool that's used by WisDOT staff to verify that your contractor data packet integrity is good. So if you don't run it, we're going to run it and find the errors anyway. So it's best that you just do it and make sure we don't have to send things back to you. Next, we're going to cover some of the visibility checks we can now do with our tools in Civil 3D. One of our goals over the past year was to create a suite of tools that help us with our site distance analysis. The first one is just for your general site distance along a roadway. It checks for site distance at whatever interval that you choose and whatever range of stationing that you choose. You can choose the required site distance as well as your object height and eye height. There are multiple output options for this tool. You can choose to do 3D sight lines, that's shown in the image. You can have a report, and you can have a profile object where the profile elevations represent site distance at any given location. One nice thing about this tool is it accepts multiple obstruction surfaces. So not only do you have your terrain surface, but you can create obstruction surfaces that represent tree lines, buildings, fences, or other objects that could be obstructing site visibility along your roadway. The next tool we introduced for visibility checks is our intersection site distance tool. It works very similar to the site distance tool, but it's intended for intersection site analysis. It checks the clear site window for intersection site distance. Then it outputs grouped 3D lines that represent obstructed and unobstructed site, as shown in the image here. Much like the regular site distance tool, this can also check against multiple obstruction surfaces. So you can pick your terrain surface as well as many obstruction surfaces as you like. When building these site distance tools, we realized we needed a quick way to build these obstruction surfaces. We're calling these surfaces wall surfaces. That's where the Create Wall Surface tool comes in. It creates nearly vertical surfaces that can be used as obstructions, and it's very useful for these site distance analyses. The surfaces are created by selecting 3D objects such as survey figures, feature lines, or 3D polylines. You can then choose to project that object in a nearly vertical fashion, either by the height above the surface at any given point, a minimum height above the surface, or at up to a certain elevation. There's a couple examples shown in the image. The image on the left was used to create a tree line. Here, we selected a feature line that represented the tree line, projected that surface upward to 20 feet at any given point. So the top of this wall is actually variable depending on the surface below it. The object on the right that sort of looks like a cube was a building. Here we selected a feature line that represented the building pad, and we told it to go above the surface by 20 feet as the minimum height. This creates a flat top surface that represents a building. The final visibility check tool that we provide is the Profile Site Distance tool. This tool is geared towards planning level analysis, where you don't have any terrain surface to go by. You may have nothing more than a profile from an as-built or a profile from a surveyed centerline. This tool checks site distance along a profile by projecting a line along that profile. This one also has multiple output options. You can create 2D sight lines as shown in the image that show the obstructed and unobstructed sight lines. It can create a report, and it also can create the profile that represent site distance at any given station. It's important to note that this only analyzes a profile and does not account for 3D roadway geometry or terrain. So again, it's really intended for planning level analysis. Once you have surfaces and begin your design, it's better to use the 3D site analysis tools we provide. For more information about these visibility check tools, be sure to attend Steve Popke's class on Wednesday covering them. The next tool to help with design efficiency is called the Alignments from Intersection Blocks tool. This tool creates alignments from WisDOT intersection blocks. Many of you may be familiar with our Alignments from Beam Guard Blocks tool. This works very similarly. It provides standardized naming, layers, and styles for the resulting alignments. It also supports iterative intersection design by allowing you to rerun the tool if you need to make a change to the intersection block. The resulting named objects are compatible with our provided Assign Corridor Targets CSV files. Let's do a quick demo. So here we have a drawing, and we've placed a couple of our WisDOT intersection blocks here at this intersection. So to use the tool, I'm going to go to the WisDOT Design tab, the Design panel, Alignment menu, and we have Create Alignments from Int Block. I'm going to go ahead and select one of the blocks, and then it's prompting me to select the main road alignment and then the side road alignment. The reason that it's doing that, it's going to use those alignments to properly name all the alignments that we're going to create from this block. So there it tells you that the process is complete and it's created a folder to place those alignments. So let's check that out. And these all come in as miscellaneous alignments. So here, let me expand this, and you can see we have all these various alignments in here. Just go ahead and select these to highlight them. You can see you have all those alignments. And you can see we've got a naming convention that has been adopted for these. So you shouldn't really have too many edits as far as naming goes. Let's repeat the command and we can do the other side of the intersection. We'll select the block, select the main road alignment, select the side road alignment, and now we have the rest of the alignments of the intersection in that folder. So you can see we have the quadrants here to help you distinguish which alignments are which. Now let's say, for instance, we made a design change. Let's say that we actually wanted the skew a little different, and we wanted this radius to be slightly different. Let's make a couple grip edits there just for the sake of demonstration. And we'll go ahead and run this again. Now, as long as I did not rename any of these alignments that I created initially, it's going to go ahead and update the alignments that were made. So again, I'll select my block, select my main road alignment and my side road alignment. You can see everything goes back up to date. So real quick, easy way to create your alignments from your layout if you use the WisDOT intersection block. And then these alignments can be used for your targeting in the corridor. Next, we have the control profile editor. Well, this is a tool we've had around for quite some time, but we just recently completely rebuilt it from the ground up to fix some things folks have reported to us, enhance some things that have been requested. One thing we did is we added this tool to the right-click menu for alignments. So if you right-click on any alignment, you'll see the control profile editor there. Just makes it real quick and easy to get to it instead of having to go through the ribbon tabs and finding it in the menu and things like that. Another cool feature is that for any value that you'd be entering for elevation, which, as you know from this tool, elevation is used for things like width and slope, things like that. Anytime you enter that value, if you put a colon after it, it'll automatically calculate that value in foot per foot. So we'll demonstrate that later. In the Edit tab, we previously had a limited amount of station equation support. One thing that it never did support was anytime you had a station equation where it resulted in a station that could occur more than once, or the stationing actually reversed direction, the old version could not handle that. Now that is all fully supported, so you shouldn't run into any issues with station equations. The previous version did not allow you to edit the stations in the Edit tab under the grid here. Now you're able to do that, and the tool can keep track of things. Perhaps if you were to reorder station values, it knows what to do there. The previous version, you always had to click a update profile from table button in order to update the profile in your drawing. Now when you edit these values in this grid, they're live and connected to your profile. So as soon as you make an edit here, the profile is updated instantaneously. There's no need to click any extra buttons or anything like that. And then we've made it more flexible to create your control profiles from a CSV. You actually get another dialog box that allows you to select which profiles you want to create. You can edit values at that time. So we'll go ahead and demonstrate that too. So with that, we'll just hop right into it. Switch over to my demo drawing. All right, so first of all, as usual, the control profile editor is available from the WisDOT Design tab, Design Panel, Profile menu. You can see it's right at the top of the list. Just to show that now that if you select any alignment and I right click, I can get to the control profile editor that way as well. One thing that is a little bit more intuitive about the tool is if you start the control profile editor with the right click menu and the alignment that you had selected is an alignment that did not have any control profiles associated with it, it automatically starts with the Create tab. Now, on the other hand, let me select this other alignment, our main road here, and I right click and I go to Control Profile Editor. You can see it starts with the Edit tab. So just a little bit more intelligence there as far as what your next step might be, whether it's to edit a profile or to create a profile. Now, it's not to say that you can't just go ahead and switch over and create more profiles if you already have some, or do it that way, but it's just trying to save you one click with the probability that you're probably going to go to the Edit tab. So let's go back to the Create tab, and I'm going to go to that alignment that did not have any control profiles. Same as before, you put in a name, you put in your station range, put in a value. Now, let's say, for instance, you wanted these values to represent slope. And let's say you had a slope of, say, 3.5 to 1. Well, you would need to know the decimal version of that in foot per foot for this tool to work properly with the WisDOT subassemblies. So instead of having to calculate that in your head or get a calculator, now if you put 3.5 or whatever your slope is and put a colon, you can see it automatically converts that to decimal form in foot per foot. So just a real quick, easy way for you to get those values and not have to think about it. Now, the one thing I really want to show off on this Create tab is how you can use the CSV file to create the profiles quickly. Now, you can always have your own CSV file and browse that file, but for this demonstration, I'm going to use the WisDOT default. One more feature we added is this View Default button. This opens the CSV file in Excel for you. It's read-only, but that way you don't have, if you ever wondered, like, where is this magic WisDOT CSV file with all the control profiles, you don't have to go hunting for it or know where that is. Just opens it for you in read-only, and if you wanted to use it and then change it for your own purposes, you can do a file save as at this point and use it however you need to. So just sort of a quick access button we've added. So I'm just going to use the WisDOT default as is, and I'm going to go ahead and hit Create. So now we get a new dialog box. What's nice about this is maybe I only wanted a few of these. I can uncheck, whichever ones I don't want, or check the ones I want. So this gives you the ability to narrow in exactly what you want for the WisDOT default profiles. Another thing you can do here is you can see it automatically gives you a preview of what the name is going to be for each of these. Well, maybe perhaps you wanted to modify the name. I could put a different value in here for any of these names and just sort of modify them on the fly. I don't have to create the profiles, then go back, rename them, or anything like that. I can change the values. Again, maybe I wanted this to be 3.5 to 1 again. So I'll put 3.5 and I'll put the colon. And as soon as I exit that cell, you can see it calculates the value for you. So very handy. And of course, you can always edit the descriptions here as well. So let's just go ahead and we'll create all those. Gives you a progress meter, so it gives you an idea that it's actually doing something. So now if I go into my 4th Avenue profiles, you can see I have all my control profiles listed here now. They were created. So very handy that way. Let's jump over to the Edit tab, and I'm going to switch over to our main roadway here. You can see now that I can edit any of the values in this grid. So let's just say we want this, we got a lot of them in here. Let's do this 331, 55, 14. Let's say this, we actually wanted 331, 56. Now when I hit enter, you're going to see that profile on the right edit immediately because it's got a live connection. So there you go. Now you have the update. I didn't have to click any additional buttons. You're good to go. So another feature here is, again, the full station equation support. So if I have a situation where I have a station equation that results in a station that might occur more than once, it's going to be able to handle that for you. So here I've got that situation. Up ahead, I have a station equation here, and it says station back 390 plus 00. But then station ahead is 388 plus 00. Well, that means I got station 389. That's going to, for instance, that's going to occur more than once. So what happens when I put station 389 in here? First, let's make sure I don't already have it in there. I do, and that's fine. Let's delete it out of there. Let's just get rid of all these. See, I can select multiple here, and I can go remove, and it takes care of them all at once. So that select multiple is kind of slick too. So let's go ahead and put that 389 in there. And let's just put 1 in here just to show how it works. I'll click add. And now it says, okay, wait a minute. Station 389 occurs more than once. Which one do you want? So here you can choose based on the raw station, the first one or the second one, which one I want. So I'll just go ahead and pick the first one. And now I have that additional profile point in there. Another thing we added here is the profile view creation. Usually not needed to have profile views for these control profiles, but if you do need one, this automatically sets up the name for you, so you don't have to type that in. Just a nice little quick thing that can save you a few steps. If for some reason I didn't want to do a certain thing, the undo will still work with this, so I'm just going to hit undo a few times. And there you can see I got all those points back in. The thing with the undo is that if you use undo, you're probably going to want to just do a refresh to make sure your table is all up to date. Then you get all those points back in here. So that's the new control profile editor. To see the control profile editor in action, join Eric Gates on Thursday morning at 10:50 for his presentation. WisDOT Profile Control, take control of the transitions. Another new tool that we introduced this year is the Create Typical from Assembly tool. So the idea here is you're not going to get a final typical section by using this tool, but it's going to give you a good start. So a request that we had is like, I have these assemblies and they represent what my roadway should be. I'd really like to just make a typical section out of it. So we did just that. What it does is it creates a basic typical section from an assembly object. Basically, all you do is select the assembly. You can just look by the animation on the screen. You select the assembly. It'll prompt you for a vertical exaggeration. So you can exaggerate this whatever you want. And the example I'm showing on the screen here, I'm exaggerating it by 2. So I select it. I put in 2 in this case. It wants to know a text height because you have your drawing set to a certain scale. And you got to have your text a certain size, paper space wise. So you got to put in a text height. And then you place where you want the typical section, and you're good to go. So what happens is all the links from the assembly become just line objects, and all the slope labels become M-text. Now it's important to know is what you see is what you get kind of situation. So if you want slopes in a certain location on your assembly, you got to have your code set up in such a way that you'll see slopes on your assembly. Or if you want to see lines in a certain location, your code set needs to be set up to show the appropriate links that you want to show. Also note that all the text and the lines, they do fall on the correct layer for typical sections. So then after you create that typical section, you would probably just do a copy of that and then paste it into your typical section drawing. We don't typically do our typical sections in the corridor drawing. So here's another tool we've had for quite a while. It is the Point Station Offset to UDP tool. This is another one that we kind of rebuilt from the ground up because there were some enhancements that we've been wanting to make for some time. So the new tool, if you're not familiar with it, we have user-defined properties that we associate with COGO points. And they're basically representing the points relationship to alignment. So we have the alignment name, the alignment description, the points offset from the alignment, the point station from that alignment. And then we also have an additional property for a radius. The thought being on that one is these points would often be used on intersection construction detail sheets where you have a point representing the center of maybe a curb return and you need to call out that radius. So we attach that radius value to the points radius UDP, and then you can use it as in labels and tables, things like that. The other nice feature of this tool is it can reference two different alignments. So thinking back to that radius point, the center of arc for a curb return, you may want to reference that station offset from the side road, and you also might want to reference the station and offset from the main road. So it gives you those two options. So we'll just go ahead and demonstrate this one too, just to show off some of the new functionality. So this is a really slimmed down drawing. I mean, normally you'd probably have a lot more points to this. I only have 4, 1, 2, 3, 4, just to represent these curb return, the center of radius points. And I've got a table that is, it's just a Kogo point table. It's a Civil 3D table. It's got your point number, and I got station offset, one for main road and one for side road. The coordinates, radius value, and of course the elevation. So you can see that like a lot of zeros in the table. We don't have those Kogo point properties set up yet. If I were to just select one of these points and go to properties, you can see I'll scroll down. Here's our USWI alignments. This is the UDP that WisDOT uses for this situation. See, nothing's populated in here yet. So that's where the tool comes in. So the tool can be accessed from the WisDOT Design tab, Design panel, and then Points, Point Station Offset to UDP. And this is the dialog that'll come up. So from here, typically you would organize these points into various point groups. You know, maybe you'd have a point group for one intersection, and then you'd have a point group for another intersection, just to keep them organized and make sure you're assigning the correct properties to each group of points. I've already created a point group here. I called it int points for intersection points. One thing, if you didn't have a point group, we just give you a little shortcut button that just opens up the point group creation. You get a new point group, you can name it. There's so many different ways that you can include points in a particular point group. So you can utilize all those tools in here to go ahead and do that. Again, we have our point group, so I'm just going to select it. And we want alignment 1 to be our main road, Highway 25. We want alignment 2 to be our side road, local 4th Avenue. And there's no properties currently assigned to these points right now. So whether I check this button or not, it's not going to, or check this box or not, it's not going to make any difference. This just allows you to, if you've already got properties assigned, it won't overwrite those. It'll update those. Maybe if your point moved and the station then moved, it'll update those values, but it's not going to reassign a new alignment to that point when you go ahead and run this. And then this is the brand new option that we've introduced with this tool. It's the detect radius points. So this is pretty cool because previously we didn't have an automated way to populate the radius property in here. So you basically would have to go ahead and measure the radius of each curb return and then punch it in here, and then hopefully you didn't, you know, hit the wrong number or something. So it wasn't very automated at all. So the way this detect radius points works is it'll search for either your active drawing and or any X references that you select in here. And it'll look for any object that has an arc with a center point that matches where your Kogo point is. So, and that could be alignments, it could be arcs, you know, whatever. Even if it's an alignment that's a really long alignment, but it's got one component, one curve in that alignment where the center point matches that point, it'll find that and it'll tell you what the radius is to that. So the best way to explain this one is really by demonstration. So in this case, I don't have any arcs in this active drawing that are going to match these center of curve points because I've X referenced in my geometry. So that XREF in this case is my my pavement file. So I don't need to select my current plan sheet. There's no arcs in there that match. I don't need to select my topo file. There's no arcs in there that are going to match, but they are in my pavement file. Now, it's very possible that it could find multiple arcs that would match that point. And these curb returns are a perfect example. The center point for the flange, the face, and the back are all the same. So which radius should it use? You need to tell it somehow what radius to use. And we give you multiple options. It'll either prompt you for which one to use. So you'll get we'll show that off next. It can use the smallest one for all the points, always use the smallest radius, or you could always use the largest radius. If all you have are curb returns, in most cases, you're probably going to use the largest radius, get the radius to the flange line. But just to show off how this prompt feature works, we'll select that one. And then, of course, it'll give you the option of what precision of the radius value you want to use. Do you want to report the radius to the even foot, to the nearest tenth of a foot, or what have you? We'll just leave it at 0, so that'll be the nearest foot. And we'll go ahead and apply this. And you can see it's going ahead and prompting you. So what's cool about this is here's the 3 radius values that it found. So if I select each one of these, it gives you a temporary graphic to let you know which ones are which. So in this case, I want the flange line. I'm going to pick 70. If I decided, I didn't want to really apply a radius to this point, or none of these are actually the radius of values I want, I can always skip this. If I hit skip, it'll skip this point, go to the next one. If I hit cancel, it's going to cancel out of the radius property assignment operation altogether. So I'm going to click OK. I like that 70. That's what I'm looking for. Now I'm on the next one. Again, I've got the 3 values. I can select each one to see which one is the correct one. I want 40. And again, we want 70. And we want 40. So now, if I go ahead and as long as I got this one on the screen, we'll select it. Go to Properties. I've got all my values populated. I got my alignment 1 is 25. My alignment 1 description is SDH 25. My alignment 2 is local 4th. My description for alignment 2 is 4th Avenue. It even gives you the side in left and right. So left side, it's left of 25 and it's right of 4th Avenue. I got my offset of 64 feet from 25 and my offset of 55 from 4th Avenue. And then here's our station values for Highway 25 and 4th Avenue. And then here's the cool radius feature here. I didn't have to go and measure anything. It found the arcs of interest, and we told it which one we wanted, and those values are automatically populated. So some really cool, nice new features that we've added to the tool. One more thing that we added that has sort of tripped up people in the past is for this to work, you have to have the user-defined property classification of USWI in the drawing. And if you don't have that in your drawing or your template, this isn't going to do anything, or it wouldn't do anything in the past. Now, if this isn't in here and you run this tool, it's going to automatically create that in your file. So you don't have to worry about, do I have the USWI alignments classification or not? It's in there. If it's not in there, it's going to create it for you on the fly, and you'll be good to go. And you can see all those values got populated in my point table here. All right, this is about the last tool we have time for, and this is kind of a quick one. So the Assign XREFs to Layers tool. So this is a new one. You may or may not be familiar with our Load XREFs on Layers tool. This is a tool we've had for a while. This just allows us to attach XREFs, I'll call it the WisDOT way, which is we like our XREFs all to be on their separate unique layers. It's just easier to manage then. I mean, if you want to, instead of having to unload and reload XREFs, I can just turn that layer on and off. It just makes it simpler for display purposes. And then it also makes sure that the XREF is attached using overlay versus attach, because we don't want to use the, I shouldn't say we shouldn't ever want to use, but in the vast majority of cases, we want to use overlay and we don't want our XREFs nested. Sometimes it can lead to circular references and things like that. We just want to avoid all that together. So that's what our load XREFs on layers does. So the purpose of this tool is, well, what if I didn't use the load XREFs on layers tool? Well, this cleans up the mess afterwards. You run this tool and it takes all the XREFs in your drawing, puts them on their own unique layer based on our standard naming convention for the layers. And again, that gives you all the benefits. You can easily turn the XREFs on and off, and it sets them to overlay. So just a real quick kind of a cleanup after the fact tool that we added. So that's all we have time for today. I hope you enjoyed the presentation. If you have any questions, please let us know. If you ever run into any issues with any of the WisDOT tools or configuration, please contact our support mailbox. It's at support.cae@dot.wi.gov. Let us know if there's issues. Let us know if you're loving the tools too. We want to hear that as well. I hope you enjoy the rest of the workshop. Have a great week.